What are the basically, this topic will deal with the units till now, what all we have learned it here. So when you take the physical quantity, what are the basic necessity of it? So first we'll start with the basic definitions. It's a self-reading also. You can read on your own also. This is physical quantity. What are the features of physical quantity? What is the basic feature like? So first what happened, it can be measured. One which can be measured is only what happened, we'll call it as a physical quantity. And we are dealing with only physical quantity, which can be measured. And through which, and using this physical quantity, through which various physical laws can be explained, like F equal to ma. So what I'm doing, I'm expressing one physical law using that particular physical quantity. What is the physical quantity? Force, mass, acceleration, velocity. I'm expressing some basic nature's laws using that one. So that is the requirement of physical quantity, through which various physical laws can be expressed. Sorry, physical happenings. Happenings can be explained in the form of law, like photoelectric effect. It's a naturally happening thing that I'm able to make it as a law, like F equal to m, a good example. So okay, getting this. So these are the basic requirement of a physical quantity. Next, how do a physical quantity has to be expressed here? So expressing physical quantity. A physical quantity, I'll just write Q, will have a magnitude behind the unit. So what do this? This is a physical quantity. This corresponds for magnitude, and this U corresponds for unit here. What is the basic physical quantity? It's like a magnitude into unit, that one. So this unit will tell us this one, and this magnitude will tell us how much. Like suppose say 10 meter. Let's have some small explanation. And length of the body is 10 meter. What do you mean by that one? It is 10 times of 1 meter. Okay, this one. So how do the physical quantity remain fixed? So how do this magnitude and unit will be rated? They'll be inversely proportional. Shall we put, because physical quantity is so like a 10 kgs. The 10 kg is a constant. The physical quantity is a constant, that one. So magnitude and unit open, they'll be inversely proportional. Just having a firm idea like this, And what we can do is like the given physical quantity will remain as it is. So you can change its units also. Then proportionally the magnitude will change, but overall the amount of physical quantity will be there as a 10 kg. I think instead of wasting time much, let me put it here. What is this 10 magnitude? What is kg unit? Can I express this in terms of gram? What is 1 kg? 1000 grams. 10,000 grams here. So what happened now? Earlier the 10 kg has become 1000 grams. So when you change the units, what happened? The magnitude will change. So shall we write N1U1 equal to N2U2? Fine. So next again, what are the types of physical quantities? Some physical quantities are there which are only ratio. So only it will become a ratio. So like a good example of only ratio means like a strain, how you define change in length by, it's a ratio, it will not have any units. There are some physical quantities which will not have units. So what are that? The ratios. Ratios, what happen? Is they will not have units here. If a ratio of two similar quantities, it will not have a unit, that one. So then relative density, example, relative density. These are the examples of this one. Then refractive index. All these are ratios will not have units. So there are, it's also a physical quantity, we'll call it. It will have magnitude, but will not have a unit. So these things are there. Okay, next afterwards, we'll go for the scalar. I think you are very much familiar with this. Will have only magnitude. Will have magnitude. Anyway, like it will have units. It's not that it will not have units here. A good example is temperature. Will not have units. And ratio, what happened, will have magnitude, like refractive index 2, 2.5, 1.5, will write it. Now similarly scalar, only magnitude, will not have direction. Anyway, like where it's having, and it will have units here, only magnitude, and will have units. Example is temperature, then distance. It's having magnitude as well as unit. No? So next what we're having is vectors. What are vectors? Having both magnitude, direction, and units. Okay, we are going to come across all these quantities here. Anyway, like we are not much bothered about to specify the direction. Already we are discussed here in the vector chapter. So we'll focus more on the magnitude and the unit idea, that one. Okay, with this. Okay, now after this, again, what are these quantities are there? No? This particular physical quantities, we can divide this into two parts, fundamental and derived. I directly take a text from the book because again, writing it will take a lot of time because I want to go into the numericals as early as possible. No, again, the physical quantities, you can divide that into two types. One is fundamental and derived quantities. So what do you mean by fundamental? I think you have to read theory once. Nothing is there. Only read theory once. Okay, I'll read for you people. Which exist in nature, there are only few quantities which are independent of all other quantities and do not require the help of any other physical quantity for their definition. So there's a meaning of, so don't memorize this, please. I'm telling this one. Better read and think. You have to read and think it here. So a good example, length. To define length, what shall I do? Absolute or fundamental quantities or base quantities. So to define length, what shall I do? I'll not go for anywhere. To define current, what will happen? I'm not dependent on anything. I directly have a, sir, how you define length? 1 meter. I think in books they're given, you read it. I think in chemistry you might have come across SI units there. So we have a standards, that particular thing for a, like a mass, length, time, temperature, luminous intensity, electric current, amount of substance. We have a standards, that one. And when we are picking up that standard, the standard should not vary with the time. Should not, what happened, should not, the standard should not vary with the time, and the standard should be easily available. I think there are so many things are there, you read once. So like this, we'll define the length, mass, time. So these are things. So now to define the length, I need not to bother any other physical quantity. Means I want to define the length, the physical quantity, the length, standard you need for that one. I need not to take help of mass, time, temperature. Directly I can define the length. I want to define mass. So like this, these are called like a fundamental quantities, and the units related to them are called as the fundamental units here. And for mass, we'll put kg, length meter, time seconds, temperature Kelvin, luminous intensity, candela, electric current ampere, and amount of substance mole. Even electric current is a fundamental. But sir, what is the current rate of flow of charge? I think maybe in 1970s or something, they made it as a fundamental. Electric current is a fundamental, that one, not a charge. I think this is something very confusing because how you define current? Rate of flow of charge. Actually, we think charge is a fundamental, but here we make electric current as fundamental. The reason for that, if you go for electromagnetism, no, the force of interaction between two wires, there is nothing but will become a from there I can define it very systematically. Okay, there's about what about derived quantities? Look at the one which are available through multiplication, division, or different powers of fundamental quantities. All other physical quantities can be derived by suitable multiplication or division of different powers of fundamental quantities. So like this called as a derived example force. How force will come? I'll just put simple idea like this. Force what happen will come mass. What is the acceleration again? Acceleration again you are going to write distance by time. Also like a velocity by time. Even velocity, further what you're going to write distance by time square. So now look at this. Force is what? Fundamental, no? It depends upon what? Mass, position, mass, distance, mass, length, and time. So therefore, this will become a derived quantity. And the unit for this will become a derived unit. So like that, again, we have fundamental and derived units here. Supplementary quantities, so that one, to express that phase angle, radian and steradian, they will not have any dimensions. Phase angle, radian, and solid angle is steradian. So what do you mean by solid angle? Solid angle of a sphere subtended by sphere will be 4 pi. So solid angle we do express like this. What is the angle subtended by this one? The solid angle you have to show like this. And there's a symbol. There's symbol of unit is telling. Solid angle for this, there's a symbol. So this should be equal to 2 pi 1 minus cos theta. And what is this? This is a surface. Angle subtended by the surface at point P. How to calculate theta? So you can use this particular triangle. This is like this. We show solid angle like this. This we know angle, plane angle. This called a solid angle. Angle subtended by the surface at a point. This is the meaning. Okay, later on I think when we go to some topics there I'll introduce. But there's a definition. I think if you better remember, because at many places I'll be using this idea, especially in surface tension, fluids, then again in thermodynamics, radiation, electrostatics, Gauss law, then electromagnetism, then again in modern physics, photoelectric effect, there I'll be using it. Almost 6-7 places will be taking help of solid angle. So how to measure the solid angle? Angle subtended by a closed or open surface at a point. It's need not always disk. Even angle subtended by the sphere at center will be 4 pi. Later we'll discuss more in detail as the topic comes. Okay, this is about like this. We have derived and fundamental quantities. So how to now? What are the units? Everything. I think you are quite familiar. Different MKS, CGS, FPS. Now we are in SI. So I am not bothered about that CGS, FPS, or even MKS also. Let's focus more on the SI units here. After this, we'll take the dimensions of a physical quantity. The simplest thing, the powers to which the powers to which fundamental quantities must be raised in order to express the physical quantity are called its dimensions. It's having a very big use of that one. It's having very big use of this one. So first we'll go for the fundamental quantity. So first we'll take we know mass. So what is the unit for that? Length. So sorry, what is the unit for that? Kg. In dimensions, we'll write it as m1. Or write only m, this one. Next again we have length, meter, this is. So then this is m, no, meter. So then this should be what happened? Should be L, capital letter, this one. Next we have time. The unit for that is seconds. Here it is t. These are, this is a quantity, units, and these are dimensions. Now, what is use of dimensions? It will really help us a lot to understand the concepts. Okay, sir, what concepts? Already we know laws of motion, everything. Then what new thing to learn? Means, like, suppose say we'll start with a force. So what we have? Force here. So what is the force? You're going to write mass into acceleration. For us, it's a very small doing numerical, but for engineer, I think this is something boon, a very thing, because when you design, when you go for design, no, you just use this dimensional analysis and become very easy for him in designing thing. So then what is a force acceleration? What we can write further? Velocity into time, and this will become length by time by time. So altogether, what you can write? Mass, length, time square. So every time writing force, mass, okay, the derived quantity, this is a derived quantity. This derived quantity, how it is related to the fundamental quantities. Every time writing mass, length, time square, it will be more time consuming. Instead, what happen? I want to go for a symbolic form. So this force, what are the dimensions of this? M1, L1, T square. I think this is the best way of representing, no? And what is this? This is a derived quantity. It depends upon the fundamental quantities like this. And that I'm showing by dimension analysis here. So we know
-2.
-2. This is. Okay, carefully make observation. So it's nothing. Even if you want, you can go like this here. But I feel like every time writing mass, length, time, it'll become more time consuming, that one. That's why we brought it here. So what are dimensions? MLT are not dimensions, the powers. These are collected dimensions. Are you getting, no? So this particular physical quantity, I think let's go for the definition. The powers to which a fundamental quantities must be raised in order to express the given physical quantity are called its dimensions. So what are dimensions here now? These are dimensions. Okay, no, so so this we are expressing its dimension. So what is use of this now? Suppose say you want to apply a force. Tell me what you should do. The machine, what you are going to design should take care these things, no? Okay, go for now designing of machine. You are going to design a machine which will generate a force. So then what you should do, directly the machine will come like that only, will appear suddenly. No, nothing that one. The machine what happen should relate to the physical quantities like this here. It's more related to what happen, how to like a physically express that physical means using how we can using machines we can generate that physical quantity. For that purpose this dimensional analysis will help a lot. So what as a, for a student I'm sending, please design a machine which will generate a force over that one. So what you are going to do, definitely you are going to take help of this dimensionless in designing of machine. That's what I'm trying to conclude here. So like that there'll be a like a different dimensions are there. So let's go for the different physical quantities. What are the dimensions? Okay, first we'll start with velocity. Dimensions we'll put it here. M0, L1, T minus 1. Exactly. Means you want to generate a velocity, physical quantity, you want to generate a velocity, then mass not needed. That's what you mean to say here. Force already I brought it. Okay, next we'll go for the energy. Best thing, potential energy, you take it. So potential energy or kinetic energy, you can write it. M1 V square L square T minus 2. Is it okay? Because half M V square. So what about half is not related dimension. Or MGH, you do one thing, MGH. M is 1, G is what? L, T minus 2, H is L1. So this will be the energy. Okay, next again, power. Power is what? Energy by time. We define like this, no? Average power, better you go for. Sir, is it instantaneous or average? No, no. We are bothered about only the dimensions. We are not bothered about your definition here. So energy by time. So this will be M1 L square T minus 3. So sir, how you are writing power? I think you should go back to like this. Huh? So so since like what is energy? From where I brought mgh. So if you're getting confusion, you do like this. What are the dimensions of this? L1, L1, T1, and what is H? L1. Acceleration, no, it is. Okay, construct no mass dimensions will be sorry, this is m1 acceleration L by t square, distance by square of time, and h is what? Height. It will have a dimensions of L, the length, that one. Then substitute, you'll get it. So like this, what happen? Not guessing. Go back to the basic. That particular physical quantity, how it is related to fundamental quantities again. So G is not fundamental quantity. You have to express again acceleration in terms of fundamental quantity. Then you have to bring the dimensions. Okay, next we'll go for the momentum. Momentum is what? Mass into velocity. M1, L1, T minus 1. Or impulse. Same thing, no? Impulse will also have, check it, impulse will also have the same impulse and momentum. They'll be having a same dimensions here. Okay, now I think these are the quantities, what all we studied, I'm just putting it this one. Okay, next come for the torque, moment of inertia. Moment of inertia, mr square, so m1 L square T0. Torque. Torque should be like a R cross F. Or first we'll do one thing, we'll go for angular momentum, then torque will become very easy. Angular momentum, MVR, take help of simplified one, MVR, V, MVR velocity, so this will be L square T minus 1. And then how you define torque? Rate of change of angular momentum. Rate of change of angular momentum. So shall we bring m1 L square t minus 2? So torque and energy, are they have same dimensions? Because what is energy? Energy is nothing but the work done, no? And what is work done? Force into displacement. What is the torque? They're also force into that position vector. So these are things which will trouble you. Huh? Means like two physical quantities, can they have same dimensions? Yes, you look at the momentum impulse, you look at the energy and torque. Okay, this is about the thing. Okay, we'll go for some constants are there to find the dimensions of physical constant or quotient. So these are basic things. So first, use of dimensional analysis. I'll come for application part. I say I'm telling this one for us. It's a just mere I'm writing as a teacher, first teacher I'm writing it. But for engineer, this is a boon. I think when you become especially mechanical civil engineer, no, or any most other than software engineer, you are going to take help of this dimensional analysis when you encounter new thing. If you want, you can type it in Google, no? How mechanical engineering designing of machines will use dimension analysis. You'll give some plenty of explanation, some more than around 100 pages are there. If you have patience, you read it. Designing purpose, not for repair, mechanical, not mechanics one. It's all about that in designing stage what pen we are going to take help of this very widely. And now first users of applications of dimensional analysis. The first one to find the dimensions of physical constant or coefficients. Okay, what do you mean by physical constants or coefficients here? So now example area pi r square will come. So can we find out? Yes, we can check it now. So first I'll start with area equal to we write pi r square. So what is that pi? Pi is no, it's a constant, no? It's not having any dimensions. What is area? L square. What is r? R is the distance L square. So this pi is what happened. It's a constant but no dimensions. Pi is a constant, no dimension. Okay, let's come for gravitational force. What about the G? Is it having any dimensions? Yes, if you go for the force, it's having dimensions here. So let me write G like this. What are the, in terms of dimensions, will break up this one. For G, the dimensions will be, what is F? Okay, I'll do one thing. I think now I'm writing dimensions, so don't write equal, just put it like this. So what is the dimensions of the force? I think we'll have here. Force I didn't write. Force M1 L1 T minus 2. M1 L1 T minus 2. Then dimensions of length will be M0 L square. This will be M1 M1. What are the dimensions of gravitational constant? M minus 1, M minus 1, L cube, T minus 2. Okay, agree this? Like this. So what is this gravitational constant? Is it having any dimensions? Yes, it is. So like this, some constants are there, that one. So can we find out this value? No. At least I can say that one, we determine this by experimentally. All this particular thing. Only now I'm able to tell its dimension. What about pi? Okay, I can't do that one. I have to go for experiment. I think now we don't have much. Actually, if you go for Coulomb's law, everything there, so many dimensional constants will come. Okay, one viscous drag, since you are aware. 6 pi eta RV. This 6 pi, it's a very good example I picked up. This is a constant, no dimensions. And what about this? This is a dimensional constant. How to get that eta? So eta, what happened? We'll write in dimensions like force by RV. So what is the force? M1, L1, T minus 2. R is L1. V is what? L1, T minus 1. What is the total dimensions will become?
Sir, L1 by T power 1.
Okay, this will be M1, one L1 get cancelled, so L minus 1, so T minus 1. This will be the dimensional constant. So there's a one advantage of this dimension analysis here. Okay, now first again, 2 will go for next year. To convert a physical quantity, first application to find a dimensional. To convert physical quantity from one system to another system. I think earlier, so when the books what I read were everywhere in CGS and MKS, then every time what happened in a numerical and we have to express the answer in SI. So therefore at that time I used exclusively. And later on after 1992, they made a rule that anybody who writes and publishes books should be in SI, in international standard systems. They made a rule. But I read book where it was in FPS, CGS, MKS, that one. But answer what happened, we must, even in exam, we must express in SI. So at that time, I think almost in every chapter, 70% of numericals were in other system, but our answer should be in SI. That was a big headache for us. Then solving what happened, the big headache was we used to go wrong here only. But I think by the time you came, everything, all the books, even the teacher teaching in SI, the book, everything data given SI. And hardly we know now CGS, FPS, MKS system. That one, if you go back, no, this was the most necessity for students to learn this. That's why we are just sharing that one. So if you want to take a simple thing, that one, not very big one, force, you can take it, or we can take a gravitational constant from CGS to, we'll make it as MKS, that one. I think I'll leave it, you just read it because it is of no use, especially like for your level. I think I feel no use that one. I just leave it. You refer any book, what when there he is telling CGS, how to convert the force which is there in the CGS from convert Newton into dyne, or convert dyne to Newton, or energy 1 joule to ergs. That conversion is there in the books. Okay, you do refer once. May not be very important at this particular time. That's what I feel. I'm skipping that part. Okay, now let's come for the very important, which will help us a lot to check the dimensional correctness of a physical relation. So here what happen? Here we'll use, we are going to use principle of homogeneity. This is really it's something very important for us. I think you check the advanced paper. Almost like for every 2 years is giving a question where based on dimensions you have to eliminate. Definitely, I think at least every year one question will be there where if you apply dimensions, no, you can pick up the options or you can eliminate the options. Okay, this particular way of also asking is there, especially theoretical questions come, no, you can just take help of the dimensions, check the dimension sign and proceed here. Okay, first we'll do one thing. We are very familiar with this one, no? So what are the dimensions of this? This is a distance. And what is the speed into time? This is a distance. Acceleration. This also will give me distance. So the dimensions of these quantities must be same. According to principle of homogeneity. The dimensions of LHS should be equal to dimensions of RHS. And not only just that one, even the dimensions of this. So I'll dimensions must be equal, or not I'm saying maybe equal, must be equal here. So therefore we just put in simple way. A is equal to, if A equal to B plus C, the dimensions of A must be equal to B and the dimensions of B should be equal to C. Not like the dimensions of A equal to sum of dimensions of B and C. It's a wrong thing. So what is the conclusion here? The dimensions of A is equal to dimensions of B equal to, this called like a principle of homogeneity. Not only just like this one, even it can be any order. Even it can be of any order. What is any order? Like I'll write P is equal to X plus YZ whole square. And then what is the condition? The dimensions of P should be equal to dimensions of X. The dimensions of X should be equal to product of not only individual, the dimensions of this and the dimensions of this one. So where YZ is what? Alpha, you can write it. So what we can write now? Dimensions of P is equal to dimensions of X sorry, this is, what is alpha? Alpha is YZ square, not only YZ. So you can take any equation and you can put it in dimensions. Is it satisfying or not? Then you can proceed further. Okay, good example. Okay, now we'll take some, okay, some V equal to V naught 1, no. So let me expand this, V naught. No. So what should be the condition? The dimensions of V should be equal to dimensions of this, and what should be the dimensions of this one? How to put it? So I'll put it, I'll bring symbols here, a little bit easy for you. Okay, I think not needed. Yeah, I'll write it here. No. What should be the dimensions of this? Should be equal to dimensions of V naught and this one. What should be the dimensions of E to power of minus lambda? It should not have any dimensions because the V naught is velocity, no? So the dimensions of this should be equal to this, the dimension of this total. So what should be the dimensions of lambda? The dimensions of lambda should be 1 by t. So that this will become certain, just a constant. So what is e to power of minus lambda t? This should not have any dimensions. And what should be the dimensions of lambda? That should be the reciprocal of time. I'll stress things like this. This total quantity should not have dimensions, no dimensions. But what is lambda? Lambda should have dimensions of what? T minus 1. Then only what happens, some say like lambda equal to say dimensions of, so suppose say lambda is equal to like a 2 by t, then e to power of minus 2, it's a some constant, no dimensions it will become. Write it like this. Then what is the simplification? This will become, and what is E value? 2.7, square of that, it will come around say like around 5.8. So not having any dimensions, no? So go this, I think now so some things are like a, so why can't this have dimensions? If this having dimensions, the principle of homogeneity open will go wrong. That's the core idea. I think you have to be careful exponential log trigonometric equations when they come. So let's take the one more. Yeah. So what about this quantity? The dimensions of y should be equal to dimensions of a, and the sine omega t should not have any dimensions. But whatever omega should have dimensions reciprocal of time, 1 by t. So shall we write just only the dimensions? This will be dimensions will be m0, L1, T0. Dimensions of amplitude m0, L1, T0. Dimensions of omega m0, L0, T minus 1. And there's a time, so it will have dimensions what happened t. Like that we can keep on writing, so there's no limit for this. So one more thing, I'll go for it. I think this is a van der Waals equation, which everyone is familiar. What will be the dimensions of how to proceed here now? I have brought some equation which is having plenty of operations, no addition and even multiplication, subtraction is there. The dimensions of P should be equal to dimensions of AV square. The dimensions of B should be the dimensions of the volume. Is that okay? This one, and the dimensions of these two outputs should be equal to this one. So I'll put it like that. The dimensions of A by V square should be equal to dimensions of P. Dimensions of B should be equal to dimensions of V. So now we know the dimensions of pressure and volume. So with that, we'll get the dimensions of A. How to bring the dimensions of A? So therefore, the dimensions of A should be equal to dimensions of P into dimensions of V square. So dimensions of P is what? pressure, I think I'll bring for pressure the dimensions separately. We'll do it. Pressure is what we define force by area. Force, the dimensions of force is what, like m1 L1 T minus 2, and this is L square. So this should be the dimensions will become M1 L minus 1 T minus 2. Okay, this will be the dimensions of pressure. So substitute here. So this should become M1 L1 L minus 1 T minus 1. Dimensions of volume square should be equal to M0. Volume will be L to the power of 6 T0. So these are the dimensions of A. Dimensions of B is dimensions of volume. Okay, it's quite clear. So like this will happen. This will help us. See now, sir, okay, what is there in this one? If your Van der Waals gas equation, is it important or not? I think you know enough of chemistry than me. Very important, no? And if you are designing any equipment, what happens? The equipment, what happens, should obey this. Then what are A and B? How to design that A and B? The instrument which will measure A and B. I'll keep this in the mind. I'm telling this one. It's all about for engineer. All this. This is meant for engineer to be. Let me say very clearly. Okay, like this, you can go for this one. Now, next again, the as a research tool, I think there's a second application, the fourth application. As a research tool to derive new relations. As a research tool to derive new relations. So what does it mean? Okay, let's do one thing. A student don't know much about physics. So he will do one thing. He will take a rope or a string. He will tie a particle of mass m. This is having a length L. This body is having a mass m. This is a string. And he will project it like this. And it starts moving in circular path. Then he will ask himself, okay, what is the state of string? String is taut. So there'll be a centripetal force, or this will be tension. Okay, the tension, I'll write it as F because again, T will get confused with the time. So then the student is really interested in this, how this force, mass of the body, speed, and the length are related. So it's a very sad state that in India, we just do learn this for 1 day or 1, 2, 3 hours. We'll do some problems and we'll go it. Actually, why it was kept in the beginning of chapter, the thing is like when you are entering into any concept, don't directly write centripetal force is given by mv square L and again explain some numericals. Okay, and say, okay, some 10, 15 best numericals from Olympiad book here and there and say chapter is got over and teacher is impressing student, but is not making you to think. It's the wrong thing. This was not expected. What they expected like this. Okay, there's a force. Okay, there's a force, the length. These are the physical quantities are there. Okay, any relationship between them. Then you have to get into dimensionality. You have to search. Oh, like this, they are related. Then, okay, why only this? What is use of this? There's a way of entering into the concept. I think almost mechanics got over. We never followed anything like this, no? Where this chapter should have been in the beginning first. Because see, in high school, you learn most of the things, no? You learn so many things, mass, velocity, acceleration. There's no need something you don't know anything. You know some basic science. But where we have brought this chapter, almost the mechanics got over. So that's why you find very difficult. Suddenly a concept is brought, what happens? You are unable to digest it. Sir, how come this new idea? The new idea has come from dimension analysis. Okay, at least now you got the dimension analysis approach. So whenever I bring the new concept, please build up this approach. You have to think like this. So this, sir, we know F equal to mv square r. Okay, assume that you don't know this. Now tell me what you're going to do. I'm just trying to search how this force is related to all these quantities. So what I do is like a F. So it should be related to some alpha, I don't know, mass, say some x, then velocity, yeah, and the length z. The student don't know anything. He will write like this. What is alpha? Alpha may be some constant. I'm not sure. Then shall we go for the dimensions? Equating dimensions. So what is the dimensions of the force? M1. It's a really troublesome, the way without dimensionless is the first time when you enter concept and teacher not telling dimensionless is, it's a wrong way. I think this is the way we learn. Am I right? Even the same, I am including myself also in that wrong methodology, not only this one. What are the dimensions of M? Dimensions of this M1, L0, T0, X. Or directly shall I write only Mx? Or next step we'll write it. There's a velocity M0, L1, T minus 1, Y. What about the length? M0, L1, T0, Z. Okay, let's go for. So Mx is there. For L, it will be Y plus Z. And for T, what it is? Minus Y. Okay, let's check it now. What all we have? X should be equal to 1 from this. And minus Y should be equal to 2. This is 2, not Z. So Y should be equal to 2. Y plus Z is equal to 1. So then Z should be equal to minus 1. Solving these two. So finally I am getting a force like M is how much? 1. No? So therefore this is 1. What about the Y? Y I am getting 2. And what is Z? Z I am getting minus 1. So if I put it, then what I should do? I should do the experiment. I should search for alpha. So how you find out alpha? I know the mass of the body. I know the speed what I'm giving. I know the length what I given. I'll measure the force in the string, tension. So how you measure? I'll connect one spring balance, dynamometer there, the very light dynamometer. Then I'll come to know that alpha. So this alpha you find out, you are going to find out by there's a drawback of this. Any constants are there, we cannot find out by dimension analysis. Getting now, I think this is the most best scientific way of learning the concept for the first time. I think as a teacher, it's my duty to tell that there's a way of learning. There's a way of learning, but I don't know, we have lost it. So teacher, no student, nobody is bothered because we are treating this chapter is like just like a, how many questions will come for in advance? 1, 2. And we are happy with that. Okay, you'll get rank, but no knowledge. Please do unlike, this is very important. Okay, that is not on it. So now what happened? So you have got quite independence, no? Whatever type of system. So what you should do now? So you can take some physical object and try to notice the different physical quantities that you are able to measure there and how those physical quantities are related. Then you are bringing dimensions and you are trying to check. There's a one way of trying to relate how physical quantities are related. Something that the engineer needs very much. Of course, it's having limitations, but to some extent it will help them a lot. A very big air conditioner. So air conditioner is having almost some 28 parameters are there. So what you'll do, you'll break up this into some seven or select some nine parts. Then each part, the three parts, you'll make it like a, so because the AC is what happened as it is not come no. Again, the particular air conditioner is broken up into some 10 or 15 parts. In each part, again, what will be subdivided into made up of three quantities. Then how that particular three quantities are related and what that particular quantity, like this, the designing stage will go on. Not that easy. That's why we don't like much. Okay, now since you are familiar with time period of pendulum, or since pendulum already you know, I'll bring again. Okay, this one. So time period, I'll bring it. A simple pendulum. Like this, you can take any physical system and you can start searching how things are related. So what all we have in simple pendulum? Length, it will have a speed. Okay, clear this one. So how the time period of pendulum is related to various quantities. So what all we have, mass, length, and also the weight will act, no? mg. So I'll start with them. The time period of pendulum is depends on, say I'll write once again alpha, mx, length, g. Okay, put this. So the time period of this is what happened, m0, l0, t1. Okay, this alpha, it's l1, sorry, m1, l0, t0. Length is m0, l1, t0. m0, l1, t minus 2. Okay, equate now. Again, check it. So this should be mx, ly, ly plus z. X should be 0. Okay, fine. Comparing this, then y plus z is equal to 0. Then 1 equal to minus 2z. So what is the value of z? Minus 1 by 2. Substitute that, y equal to 1 by 2. Okay, how to, this time period depends on what, like alpha, m is not there. So in place of L, what shall I write? 1 by 2. In place of G, minus 1 by 2. So therefore this will become, this alpha I don't know, I'll find out by experiment. Value. So you can take anything, not only this. You can take anything, that one. So I'll give one more very good one, which is, you are not aware of that. I'm searching for question, just give it some time. No. One more thing you see that this will be really a gas bubble, a gas bubble from an explosion underwater oscillates with a time period t proportional to proportional to pressure density of water and total energy of explosion. Okay, how that time period is related. I'll put it. Time period is proportional to this one. Okay, what are the symbols we use? The time period. I'm not very sure. Like once again, I'll bring say some beta. I took. I don't know that what is any constant is it? T equal to beta pressure. A, I'll write it. The density B, or say D, that one, because rho again will think that it's a constant. This one, and the energy, let it be. Shall we use this one? So I'm not very sure you see that one. We don't know anything about this system, no? Okay, simple pendulum, we are very sure. Okay, we don't know anything about this system. Then this should be equal to T is equal to, so this should be M0, L0, T1. Pressure, ML minus 1, T minus 2, E. Density, M1, L minus 2, T0, B. Energy, M0, sorry, M1, L square, T minus 2, C. A plus B plus C. Okay, equate things here. So A should be A plus B plus C equals 0. Then A minus 3B plus 2C equals 0. Minus 2A minus C is equal to minus 1. Solve this. Okay, this is a time period. Time period is what, like beta density, no? This will be T is power 1, no? Oh, then where I should make changes? Yeah, it is. Yeah, okay, yeah. So it will beta, I don't know, but at least I'm going to say that one. The density is how much here. This will be d to power of 1 by 2, e to power of 1 by 3, and the pressure is telling 5 by 6. The beta I'll find out by experiment. I don't know value. To be frank, I don't know value. Find out by experiment. This is something like this. Now you can go for random. Is it related? If the time period is doesn't related to density, I brought it something and all. So if not related, it will not come into picture. Like you see that one mass of the bob will not determine the time period. Like that particular quantity will it depend this mass also the mass of the bob will determine time period. The answer is no. We got this one. So is it that quantity depends on that or not? I think very important. This is what the engineer. So engineer wants to check that whether this output depends on that one. This output will have some physical quantity. Well, it depends on which input. Okay, this will not have any influence. So therefore, what happen now, since this will not show any impact on the measurement, I can minimize its effect on the, because output matters a lot. So can I compromise on this? Yes, I can compromise in designing of this. So shall I use very costly material? No, I can go for some cheaper material to some extent. Like this, when the cost is brought down. Getting son, when you purchase car, okay, how to minimize cost? Okay, the engineer open after designing again, he has to come search like which quantity I can compromise, which quantity I should not compromise, where error generate will be minimum. If I change some quality, then how error it will have impact. So many things are there. Definitely, you may not like what all I'm speaking. So definitely what you say, sir, what is use of this? When you become engineer, at least I think you'll remember me once. Ah, okay, that fellow used to say so much about this, that one. At least when you become design engineer, at least once in your profession, you'll realize with that one. Okay, that fellow used to tell. Huh? Okay, many students who are in contact with me, through social media, they do tell us, like you used to tell a lot, so many things. Then at that time we could not realize. Okay, now we are realizing the importance. Okay, there's nothing wrong, because like you are trained to do better in exam. That's all. We are just training you to do better in exam. There is a major cause for thing. Okay, let's go for some other difference. So can I express now one quantity in terms of some other quantity? So I'll start with this one. Now, these are some, if velocity, force, and time are taken to be fundamental quantities. Find dimensional formula for mass and energy. Okay, saying something, no? Fundamentals are fundamental quantity are mass, length, time. You're making, I'm changing this one. So why you're changing? Maybe in another some system, maybe in another planet, things may be like this. Hypothetical, maybe in another planet. These are the fundamentals. So what we are doing, this dimensionless is taking us to the different types of the structures, the building blocks. Later on, I think in Bohr's atomic model, you do come across. I'll do justify. So how can you write like this? How can you can change fundamentals? Maybe on planet Earth, mass, length, time. Maybe at other planet, maybe some other thing. So this is like a hypothetical. How to proceed here now. So what is telling, like find the dimensions of, let the quantity be this one. So this quantity what happen will be function of velocity, force, and time. Capital V again will become volume. I'll put it here. So this will be say some alpha, right? K again you get confused with them. So therefore I'll write some beta. This should be equal to x y t z. So now what you're bringing mass here, no? So first we'll do one thing, we'll simplify this. The dimensions of this, dimensions of velocity, m0, l1, t minus 1, x. Dimensions of force, m1, l1, t minus 2, y. Dimensions of time, m0, l0, t1, z. Okay, this I'll end up with one, my, lx plus y, t minus x, minus 2y plus z. Okay, now first part will do it, mass. So if the quantity is mass, how to express mass in terms of these velocities, everything. So if the q becomes mass here, if there's a quantity, the physical quantity. So now what are the dimensions of mass? M1, no, equate the power, that one, y should be equal to 1, x plus y should be 0, then x equal to minus 1 from this. Then if you know, and minus x minus 2y plus z equal to 0. With this, solving this, all z equal to 1. So therefore, how the mass will be related? Some beta. So x is minus 1, b minus 1. Force is how much? Y value is 1, t is 1. Okay, the mass now you can express like this here, in terms of velocity. So how mass is related? It's related to velocity, force, time. So don't write by v. I think it's not a convention to write ft by v. Any dimensions negative, so to the power minus 1. So we have to show that dimensions here only. It can be positive or negative, the dimensions. So how the mass is related? The mass is related like this. So don't write here m, that quantity, physical quantity. Because I started from here, no? If the physical quantity is mass, if you're getting confusion, write it. It is related to velocity, force, time. We don't know any other thing, that one. Any that particular. What is the beta? Beta is again a constant that has to be determined by experiment. We are not sure it is the value of how much everything. So we just leave it here. Constant to be determined by experiment. Every time you need not to write like this. So books what pen, they just ended up like this. I think this will be correct one. Huh? This way of expressing the mass in terms of velocity, force, and time. Okay, let's go for if the quantity is energy. Express next energy. Okay, now let's get into the m1 L square t minus 2. This should be equal to my solving this, y equal to 1, x plus y equal to 2. So x equal to 1 minus x minus 2y plus z equal to minus 2. Z equal to 1. So therefore, how that energy is related? Energy is related to beta BFT. Or put it, if you are just showing proportionality, bring like this. Huh? I think that this will be justified way of writing, or this one. Equal to, sir, like, okay, proportional. The mass is related to the other physical quantities by this method. But sir, you said mass is a fundamental. I'm just bringing. I can express a physical quantity in terms of any other physical quantity. Sir, any use of this is, I'm telling this one, it's all about the application part. So when we go for the different type of systems, no, this is what it is going to help you. So especially in the designing part, this is going to help you a lot. Okay, I think I'll take one more related to this. Okay, all of you are able to get the idea? Let's do one thing. One more we'll do it. If area A, velocity V, and density rho are base units, find the dimensional formula of force. Find So what we are doing, we are trying to express like this: F equal to beta area velocity density rho, yes, himself he has given. Okay, let's accept that. So then in terms of dimensions, like this is needed here, no? So that we will go for writing the dimensions, the dimensions of this will be force, it will be m1 l1 t minus 2, area m0 l square t0 x, velocity m0 l1 t minus 1 y, m0 density is what? Mass by volume. Okay, equate these two all quotients, you equate. Before that, let me simplify one more step. mz L 2x plus y minus 3z. What about the time? Time will be minus 5. Z equal to 1, y equal to 2, 2x plus y minus 3z equal to 1. Inverse value of z, 2 minus x equal to 1 by 2. Z equal to 1. No? This is 2 minus 3. I think it will be 1. Huh? Check it once. X will become equal to 1. So now that force, what happened, we can express its dimensions in terms of that. X is 1. No? So this is A. Velocity is 2. A V square rho. This is very important. Huh? It will, even in advance, they prefer to ask this one. If the speed of light, one more large problem in this, speed of light c, acceleration due to gravity g, and the pressure p are taken, fundamental units are taken as fundamental units. Find the dimensions of gravitational constant. Find the Okay, I brought some really different quantities here. How to get into this one? So first, what are the dimensional constants of G? M minus 1, L, 3, t minus 2. I think first you should have idea. And what we are trying to do, the gravitational constant we are trying to express in terms of speed of light. Okay, agree this as a function of, if you want, you can write instead of beta, you can write as a function of, or in terms of that. So we'll put dimensions m minus 1 L cube t minus 2. This will be speed of light m0 dimensions of pressure m1 L minus 1 t minus 2, pressure force by area. Yeah. So equating this, mz Lx plus y minus z, time will be solving this, z equal to minus 1 x plus y minus z equal to 3, minus 2 is equal to minus x minus 2y minus 2z. Anybody values? I think you have to calculate. Z is minus 1, okay, then x and y has to be determined. I'll put x0, y2. Okay, some of you given that. Okay, fine, x0. Then y will become 2. Okay, like this, the gravitational constant. So now again, so why I brought this particular problem? You may think that one physical quantity, even the gravitational constant or coefficient of viscosity, I can express in any other thing. Agree this? So any quantity now, either say constant or a physical quantity, I can express in terms of any other quantity. I can make them as a fundamental units. I can express it. I think there's a wide way of asking the questions for you. So what is this? Expressing one physical quantity in terms of other physical quantity. The dimension analysis is going to help us a lot. Okay, this is about the basic core idea. And now, what about the some limitations? I'll search one. One document is there. Now, the last discussion is something very important. Okay, now, shall we feel happy that yes, now the dimension analysis, all and soul will solve all the problems. And we can just do the research happily. We can do our research very happily. Okay, let's see that. What difficulties? Is it everything now? Okay, we got some sort like a magical method now. So first, look, I'm going to analyze. Now, is it really beneficial in every way? That's what I'll call it, limitations of dimension analysis. Now, if you see that if dimensions are given, physical quantity may not be unique, as many physical quantities have same dimensions. For example, if dimension formula of a quantity, it may be work or energy. Am I right? So look at the first point I'll try to stress. Impulse and change in momentum. This is a thing. Second, work done and energy. Are the quantities same? Work done and energy, are the quantities same? No, work done is physical quantity, energy is the physical quantity. Impulse and change in momentum, work done and energy. So can they be are both are different physical but they're having same dimensions. So this is one thing troublesome for us. So with this, what we can say, these two physical quantities are same. The nature are different. Am I right? Work done, impulse and change in momentum, work done and energy. Like this, I can go for next. The pressure and the energy density, they will have same units. Pressure is totally different, and energy density is totally different. Two different physical, but they're having same dimensions. So that is the one troublesome here. Unique spelling. So all physical quantities will happen. Some these two are not having unique, but look at the force and velocity. They're having unique dimension, but these two physical quantities, they're having same dimension. So that will trouble us a lot. Means no, you have first time you are gone and you are designing. Okay, then you got the dimensions that of pressure. So that physical quantity, will you conclude that is it a pressure or energy density? God only knows. Again, you have to take help of experiment, not the dimensionless. Are you getting no? You have taken a system. There are several quantities are there, and when you combine them all, and the output when you go in, no, the output what happen? You get the dimensions of pressure. Will you sure you are going to confirm it's a pressure? No, it may be energy density. So again, what I should do? I should take help of the experiment details only to confirm whether it's a physical quantity, say the output of that given system is it pressure or energy, that one. Through dimensions, I cannot differentiate. Okay, got the idea? There's a meaning of that. A numerical constant have no dimensions such as 1 by 2, 1, 2 pi cannot be deduced by the method of dimension. I think I told you, no, simple pendulum 2 pi, we cannot derive by dimension analysis. It has to be determined by experiment. I think in every relationship I show, no, some beta I took it, and it has to be determined by experiment. There's no other way. The method of dimensions cannot be used to derive relations other than the product of power functions. I think this is something very, y equal to a sin o cannot be derived. You cannot derive this one. The equation is dimensionally correct, but you cannot derive this. The method of dimensions cannot be used to derive relations other than the product of power functions. So no, what to do with sine? Can you predict sine using dimension analysis? This harmonic function cannot be predicted here. We can predict y and a, but we can't predict the harmonic, and we can't even along with this. I'll write one more. So you can't predict this exponential. Are you able to understand? We can't predict here. We can predict this square, anything okay, but we can't predict this exponential, logarithmic, sine. So these mathematical operators cannot be predicted using dimension analysis. I think we can't derive this, but dimensionally correct it is. Able to understand? I'm just saying that one. You can't predict sine exponential. That's all. Finish all. Simplest logical explanation I'm giving. Using dimension analysis, the sine and exponential cannot be predicted. That's what he mean to say. No, the method of dimensions cannot be applied to derive formula if it in mechanics a physical quantity depends on more than three physical quantities, as then there will be less number of equations than the unknowns. How come? Okay, shall we try this? Maybe it's just putting. Can't we derive? Okay, that is telling one equation also he has given. And it's still not possible. Okay, we'll do one thing. Why to accept him blindly? We'll analyze. We'll fight for it. Therefore, first one, A, B, C. Now I'm coming for the fourth one. time period equal 2 pi root of I mgl. So we know moment of inertia. So let's check only the dimensions part. Huh? Okay, this is some dimension. So this is a moment of inertia is there. Moment of inertia will be m0, sorry, m1 L square T0 m1 L0 T0. It's a dimensionally correct. That's what I'm trying to do here. But what he's telling, it cannot be derived. It cannot be derived means, see, it's a dimensionally correct. You solve it, you'll get it, that one. The dimensions of everything, what happen will be, so there's no problem with this equation, dimensionally correct. But it's telling cannot be derived, dimensionally correct. Any reason for that? So what we are thinking, the time period depends on moment of inertia. So I'll proceed like this. Time period as a function of moment of inertia, mass, acceleration, and length. Okay, let's check the dimensions here. So what we do, this will write it. I checked it dimensionally correct as there's no problem with this. Then moment of inertia. So this I'll write X, Y, Z, P, or A you write it. Or I think we'll go for A, B, C, D. Moment of inertia already we have dimension L, A. This will be M1, L0, T0, B. C is how much? M0, L1, T minus 2, C. M0, L1, T0, D. So this will be A plus B, L 2A plus C plus D. T is what? Minus 2C. So A plus B equal to 0. Okay, fine. 2A plus C plus D is equal to 0. And minus 2C is equal to 1. C, I got it. But what about other unknown things? How many unknowns are there here? No? A, B, C, D. Not possible, no? So what is the restriction it is putting? Able to understand? So what happened here? How many physical quantities are there? 1, 2, 3, 4. So that's what you mean to say. The method of dimensions cannot be applied to derive formula if in mechanics a physical quantity depends on more than 3. Shall I underline? More than 3 physical quantities. If it were only this much, okay, fine. But we have more than 3. Let me just highlight that there are more than 3 physical quantities are there. Now, so is it wrong? No, cannot be arrived at the conclusion. That's all. It's a dimensionally correct. Again, don't conclude it. That's why I had to show first. There's no problem with the dimensions. It's dimensionally correct, but cannot be derived. So I think it's having its own restrictions. No? So there's a physical quantity. If this physical quantity depends only on a physical quantity which depends only on 3 physical quantities can be derived using dimension analysis. There's a conclusion. I think it's a limitation. So that's why the engineer, what they do, like a system is there. There are 20, say like a 30 parameters are there. What I do, I'll break that into 10 subsystems. And in each system, the output of that subsystem, how it is related to the 3 quantities. There's one way of overcoming this particular thing. Okay, the last one. Even if a physical quantity depends on three physical quantities, out of which two have three dimensions. The formula cannot be derived by theory of dimensions. I think this is correct, no? Can be derived by theory of dimensions here. So these are the some problems what we have. This one. So these are the some limitations of the dimensions. We'll get it here. So these are some what I gave, no, are very important for you. Problems of these kind are very important. So some all of a sudden, so like I don't know concept means like some student they ask like this question I brought it, no. Oh, where it is. Yeah. So gas bubble, how it oscillates, I don't know. So nobody's asking how it works. The dimensionless is what you have to help is that one. So you may expect in exams questions of these kind, which are the new idea for you. I think you need not to bother about the how that bubble oscillates there, what are the situation, nothing to do. Getting the method? This one. So these are the some uses of the basic dimensional the analysis here. Any doubt you can ask it. For all very important words, principle of homogeneity. This is something very important. Yes. Ritika, you are right. I think I'll go back to that discussion. I'll take you to that one because not everyone is having confusion. I'll take you to that. Okay, let me save this. I'll come back to that. That. Okay, I'll take you to. Okay, no, I think the clockwise, anti-clockwise, something very important here. Are you seeing this? This. So you should rotate the screw according to this person counterclockwise till the zero of circular scale, the zero of circular scale merges with the reference line and the zero should be visible till then. Till then you have to rotate. And how many divisions it has crossed, that is the thing that one. Now 30 is there. For the zero to appear open, it has to, zero will not come from here because you're rotating in this direction. So 70 divisions will pass for this to happen, that one. So here you see that one, as you rotate like this, how many divisions? The zero is somewhere here, no? So 30 divisions will pass, no? By the time zero appears here. Then what happens? This particular screw will be here, almost near at zero. Just it will be visible. So that is what the positive zero error. So zero visible, no problem. Above reference and below reference. But some screw gauges what happen will have like this. I have adjusted this one. So you can see it. The zero is not at all visible. I think I'm trying to show it. The zero is not visible. Okay, fine. So in that case, what you have to do? You have to use this method. We can also, I'll do one thing. I'll make zero to be very nearer. You can see that. Now the studs are in contact. I think, is it visible? Studs are in contact, and you see that there's no object between the studs here. Then the zero is just above, negative zero error only. I do have a screw. I just purchased a screw gauge where I have a screw. With this, I can adjust the zero error. But all screw gauges will not be like that. So there are some screw gauges other where you can adjust it to display for students, not to show that I brought it here. This one. Now I can adjust this. Now look at the zero now, not there, not visible, huh? But the studs are in contact. Got the idea, no? So this is the main idea, that one. Zero visible, above reference line, below reference. Above reference line, negative zero error. Below reference line, positive zero. But zero not visible, I think you should rotate the screw. Okay, fine. Okay, I think I'll stop the class here. Yeah. Let's see. That Singate textbook you can refer. Units and dimensions I just picked up from Singate textbook. All this, you can refer that. Huh?
Sir,
Ah. Yes, ma. Yeah.
sir, when the studs are in contact and to fix the object, we need to rotate in anti-clockwise only, right, sir? To fix the object in between them.
It must be, no? You must rotate anti-clockwise. I think, okay, then you're asking something. Yeah, I think it is there, no? With respect to me, it is, no? So then only if I rotate like this, you can look at my fingers movement. Okay, got this one. So now to tighten, it'll be like this. We have one more called like a backlash error. One more last thing, backlash error. Let me wind up here. Very small topic is there. What is the backlash error? So as you rotate, as I rotate here, no, the displacement, the circular displacement and linear displacement of stud should be proportional. But what happens as this screw gauge becomes old, some 4 or 5 or 6, 7 years like that, and because of what will happen, the rupture, better you can call. What is the rupture? Inside the screw, rupture will take place. Then the angular displacement will not be proportional to linear displacement. Means if I give one full rotation like this, I give one full rotation, then the screw, what happened, should have certain displacement. I'll design the screw gauge like this. But what will happen due to wear and tear or due to rupture of the parts, the angular displacement of the screw and the linear displacement of screw, there's a linear displacement, the stud moment will not be proportional. Then what you can say that a slipping will occur. Then definitely what happen, there'll be an error. They'll call it a backlash error. And you should not do reading like this. Huh? Then slipping of screw will take place. Are you getting the idea? So you should not, so when you're taking reading, no, suppose a stud is there like this, they're in contact. You want to keep an object. What you should do? You should rotate gently. You should not rotate like this also. Chances of slipping will occur, and that's called a backlash error. Backlash, I think slipping will take place, means the angular displacement, linear displacement will not be equal. So therefore, what you should do, you should rotate it gently. I'm using word gently. This one. Let it take some time, no problem. Let it take some time. So it should be like this. Huh? Then I want to fix an object. Okay, there's an object which I want to fix it up. Okay, there's an object. Now I fixed it. So some object I fixed it here. So then what happen? You should rotate like this. By the time, once the both the studs come in contact with the object, no, you get a some tuck tuck sound, that one. You have to stop rotating it, then take the reading. But you should not do like this. There's a wrong thing. You should not do like this. Then a backlash error will come. So therefore, what you should do, you should rotate the screw in one direction only, like this. You should not do like this. But you should rotate in one direction, means it's okay. Now it is in contact. Then if you want to remove the object, you should rotate in anti-clockwise. There's no other way. But when you are rotating, when you are using it, use it in one direction. So if you are removing the object from the studs, okay, gently rotate and remove. Then you want to bring in contact. So just rotate in one direction. Keep on, but you should not do like this. Backlash error will come. So there are two reasons backlash error. One, due to wear and tear of the equipment, due to aging of equipment. The angular displacement, linear displacement will not be proportional. That's the one thing. Second thing, when you rotate in either way, when you're taking reading, it should not be rotated either way. Backlash error will come. So what are the alternatives? First thing, like rotate the screw in one direction only when you're using it. When you are closing this, rotate in one direction. Or when you're keeping any object, rotate in one direction. This is the thing. Next again, sorry, it is a 5 years old. Just take some grease, all of you grease for cycle, oil, what we say in a greasing. So here what pen, you have to apply grease. You have to drop some 2-3 drops of oil. The oil, when it goes inside, you know, that particular wear and tear, what pen, it can overcome. Some viscosity, some layer will be formed. So that what happen, we'll see that the backlash error will get minimized here. May not be get eliminated, will be minimized here. So what is the backlash error? Where the displacement of the screw and the moment of stud will not be proportional, where slipping will occur. This is called a backlash error. Got it? Okay, I'll stop the class. Okay, thank you all of you.
Thank you, sir.
Thank you all of you. Take care. Bye. See you. I'll give assignment on units and dimensions. Today you can work out.